Today's lesson is on the properties of exponents. We will talk about 5 different properties and talk about what they mean and why they are the way they are, do some basic examples, and then some more difficult examples for each property. Alright, so for each property, we're going to talk about the definition of the property, give a basic example, talk about what does that property mean, describe what's going on, and then give a couple examples. We're going to do this for each property. The first one is multiplying powers with the same base. And the property is when you have powers with the same base. So let's say a to the power of m times a to the power of n. They have the same base and you're multiplying. What it is you keep the same base and then you add your exponents, a to the power of m plus n. So a basic example would be x to the third times x squared. So what does that mean? This is the when in doubt you can always write it all out. X to the third would be x times x times x. And then x squared is x times x, which that now means x to the 5th power. So describe what's going on. If you have exponent 3 and then exponent 2 and your answer is 5, what's happening is you're simply adding the exponents. Alright, so now we're going to squeeze 2 examples for this property into your box. So, the first one, in parentheses, 2x to the power of negative 3 times 3x to the 5th. So, in parentheses, but all we're doing is we're multiplying. So, all of this is 2 times x to the negative 3 times 3 times x to the 5th power. So you can multiply in any order. I want you to think about how you can rearrange this. So 2 times 3, those are our coefficients, times x to the negative 3 times x to the 5th. 2 times 3 is 6, and then x to the negative 3rd times x to the 5th. Same base, add your exponents. Negative 3 plus 5 is 2, 6x squared. If you have room, let's do one more. X to the negative 4th times x to the negative 4th. Add your exponents. Negative 4 plus negative 4 would be x to the negative 8. Never leave a negative exponent in your final answer. So 1 over x to the positive 8. So 2 examples for the first property where you add your exponents because you're multiplying powers with the same base. Alright, the next property, raising a power to a power. And the property says that if you have base a to the power of m and you raise that to the power of n, it equals a to the power of m times n. So a basic example would be if you had x squared to the 3rd. Let's think about what does that mean. X squared, this 3 tells you that you have 3 x squareds. X squared times x squared times x squared. And then each of those means 2 x's, x times x, x times x, and x times x. That means you have now 6. So it would be x to the power of 6. So power to a power, what are you doing? You are simply multiplying your exponents. Alright, let's do a couple examples. So, real quick, basic one, x squared to the power of 5. Multiply your exponents. So it's x to the power of 10. Let's say we have, for our second example, x to the third to the fifth times x to the third to the power of 0. Well, we would multiply exponents here, so this would be x to the 15th times x to the power of 3 times 0 is 0, and anything to the 0 power is just 1, so really this cancels out and you're left with just x to the 15th. Alright, next example, raising a product to a power. So product means multiplication. So if you have some sort of multiplication inside parentheses, a times b to the power of n, the property says your answer would be a to the power of n times b to the power of n. So an example, in parentheses, 3x squared, there's your product because it's 3 times x squared to the power of 4. And if you think about what that means, this exponent means you have everything inside parentheses 4 times. So 3x squared times 3x squared times 3x squared, squeeze one more on there, times 3x squared. So 3 times 3 times 3 times 3 is 3 to the 4th power, and then x squared times x squared times x squared times x squared. Each of those, there are 2 x's, so then when you multiply them all together, you will have 8. So 3 to the 4th and then x to the 8th, which you can go one step further and say 81 x to the 8th. To describe the property in words, for lack of a better word, we can use the word distribute, even though this is not the distributive property. We're going to distribute the exponents. So let's do a couple examples. If we have 2x to the 4th and then squared. So it's 2 to the 4th power. Remember, coefficient you treat not like a property of an exponent, but just, it would be 2 squared. And then x to the 4th to the 2nd would be x to the 8th. So 4x to the 8th. And then let's do another one. Negative 3 n to the power of 6 to the power of 4. So distribute the 4. Negative 3 to the 4th power is a positive 81, and then n to the 6th to the power of 4, n to the power of 24. Okay, 2 more properties left. This one, dividing powers with the same base. So let's see, a to the power of m over a to the power of n. So we're dividing powers that have the same base. What you do, it would keep the same base, a, to the power of m minus n. Subtract the exponents. So I'm going to, in the first example, do 2 different. X to the 5th over x to the 3rd. What does it mean? That means that you have 5 x's in the numerator and 3 in the denominator. And then you match up and cross off, and you would have 2 x's left over, x squared. which if you were to subtract the exponents, you would have gotten x squared. And then if you go backwards, if you have a smaller number in the numerator, let's change our exponent. So x to the 4th over x to the 7th. So you have 4 x's in the numerator, 7 in the denominator, and you match up and cross off. You have 3 x's left over, but then the denominator, so 1 over x to the 3rd. And if you go back, if you would have subtracted the exponents, you would have had x to the negative 3. You just have to know to go one step further, because your final answer should not have any negative exponents, to write it as 1 over x to the positive 3. So to describe in words, what you are doing for this property is you are subtract your exponents. Alright, 2 examples. Let's do one with multiple variables. X to the 9th, y to the 3rd over x to the 6th, y to the 7th. So if we just use the property, we can subtract our exponents. And you always want to match up where you have the same base. Your final answer should never have the same variables show up more than once. You can always simplify it. So 9 minus 6 is 3. So x to the 3rd power. And then y to 3 minus 7 is negative 4. So y to the power of negative 4. But go one step further. X to the 3rd stays in the numerator. Y to the 4th moves to the denominator. And then if you have room, let's do one more example. A to the negative 3 over a to the negative 1. If you subtract those exponents, negative 3, let's see, negative 3, and then you subtract negative 1, double negative means you're adding. Negative 3 plus 1 is a to the power of negative 2. Go one more step, 1 over a squared. Alright, final property, raising a quotient to a power. Quotient means fraction, any sort of division. So if you have a over b to the power of n, the answer would be a to the power of n over b to the power of n. So let's do a quick example. 3x over y to the power of 3. What does it mean? The exponent on the outside, that 3, means that you have that fraction 3 times. 3x over y times 3x over y times 3x over y. So you have 3 3's, so that would be 3 to the 3rd power. You have 3 x's, so that would be x to the 3rd power, and 3 y's, y to the 3rd power. So everything is now taken to the 3rd power. And 3 to the 3rd power is 27, so 27x to the 3rd, y to the 3rd. So similar to product to a power, quotient to a power, same thing. Basically what we're doing is we are distributing that exponent. Just want you to remember, once again, this is not the distributive property, just lack of a better word. We use the word distribute. Alright, so let's do 2 quick examples for our very last property. We can do just a real quick basic one. 3 over 5 squared simply means 3 squared over 5 squared, which is 9 over 25. Now let's do a more complicated one. 2 x to the negative 3 over 3 y to the negative 4, and the exponent is 2. So inside parentheses you technically have 4 things because it's 2 times x to the negative 3, 2 different, and 3 times y to the negative 4. This exponent has to go to everything inside parentheses. So 2 squared x to the power of, power to a power, negative 3 times 2 is negative 6, over 3 squared, and then y, power to a power, negative 4 times 2 is negative 8. So let's see, 2 squared is 4, and 3 squared is 9. And neither of those have a negative exponent, they're just coefficients by themselves. But this x to the power of negative 6, whenever you have that negative exponent, and then if it's in the numerator, send it to the denominator, make the exponent positive, and then vice versa with the y to the power of negative 8. It must go to the numerator and become positive. Alright, so there are all of your properties of exponents. You will definitely want to memorize all of these properties. However, if you ever get confused by the properties, you can always, when in doubt, write it all out and you can still get the correct answer. So practice whichever way that you are more comfortable with, either writing it out or memorizing the property. Good luck with the lesson.